I'm Zhu Lei. Today I will be presenting my course project, a mathematical error pattern classification system. This is an automated educational support system based on a hybrid architecture of rule engine and deep learning. After analyzing the limitations of existing methods, we propose a three-layer hybrid architecture. The core idea of this design is to combine the judgment ability of a rule system with the ability of a deep learning model to achieve a balance between high accuracy and broad coverage. Spatially, the first layer is a strong rule engine, responsible for handling cases that can be determined through logic. The second layer is a deep learning classifier based on MathBERT, handling complex and context-dependent cases. The third layer is weak rule post-processing, performing common sense verification and correction on low confidence predictions of the model. This layered design ensures that the system maintains high accuracy while handling complex situations. Based on analysis of educational literature, we established an error classification system comprising 6 categories. The first category is the correct answer, serving as the baseline category. The second category is calculation errors, referring to calculation mistakes made by students in operations. The third category is comprehension errors, referring to students' misunderstanding of the question information. The fourth category is missing steps, referring to the lack of necessary reasoning steps in the problem-solving process. The fifth category is unit errors, involving incorrect use of units of measurement. The sixth category is logic errors, referring to logic flows or wrong method selection in the reasoning process. The classification system comprehensively considers the characteristics of primary school mathematics and the needs of teaching practice, laying a foundation for the system's implementation.
My name is Yang Zhenyu. Next, I will introduce our technical implementation scheme and experimental results. At the rule engine level, we developed 3 specialized modules: a computational validator that uses regular expressions and a procedural computation to verify calculation steps with 100% testing accuracy, a step analyzer that applies structured analysis to detect missing steps, and a unit checker that ensures measurement unit consistency. At the deep learning level, we adopted the MathBERT, a model pre-trained specifically on mathematical corpora. To address labeled data scarcity, we used DeepSeek to generate synthetic training data that simulates student errors, resulting in 1,530 training and 270 validation samples. Using focal loss to handle class imbalance, the model achieved 87.8% validation accuracy after 5 epochs. The system, built with Flask, offers a RESTful API for real-time inference, with an average response time under 500 milliseconds, meeting interactive application requirements. Evaluated the system on 200 diverse test cases, achieving an overall macro average F1 score of 0.75. Performance varied significantly across error types. Computational errors and missed steps, primarily handled by the rule engine, achieved high F1 scores of 0.97 and 0.92 respectively. In contrast, error types dependent on the deep learning model, namely unit, comprehension, and logic errors, proved more challenging, with F1 scores of 0.67, 0.62, and 0.57 respectively, due to the complex semantic reasoning requirements. This study's primary contribution is the proposal and the validation of a 3-layer hybrid architecture for educational data analysis. we demonstrate that integrating the determinism of rule-based systems with the generalization capacity of deep learning achieves both broad case coverage and sustained accuracy. Furthermore, we establish that generating high-quality synthetic data through large language models presents a viable technical solution that authentic labeled data is scarce.